Всех выбросила, да?
Нет.
So, Biknur, you are next, yes?
Yes, yes.
Please choose your number of ticket.
Third one, maybe.
Should? Okay, please. Now I send you. So I have sent you. Okay, I see. Do you see your questions?
No. Can't see.
Please reload your page.
I can't see.
In your university page, yes?
Yes, okay. Just a second.
I think I can demonstrate you your ticket through my screen.
Yes, I can see system. Yeah, it's enough.
Mhm. You have 20 minutes, okay?
Okay.
Mhm. Алихан,
Да-да.
вот Викнур пишет, что у него свет отключили. У нас вообще сегодня crazy день, да?
У вас тоже свет? Нет, у вас свет горит?
Нет, у нас... Нет, я имею в виду... Так. А, ну, давайте вы или кто по очереди.
Ну, давайте я тогда, наверное.
Мгм. Please choose your ticket number.
Ну, следующий, наверное.
You should say number from 1 till 7. And...
Вот это. Четвертый он крикнул, третий, а четвертый давайте.
Okay.
Ticket number 4.
Okay. Now I load. Yes, you can check.
Вы в чат отправили, да?
Нет, в универ, где раздел экзамены. Ну, вообще, на вашу страничку.
В универ раздел экзамен. Сейчас. Сейчас. Где-то у нас экзамен. Вот здесь экзамен. Расписание экзаменов.
Где у вас УМКД?
А УМКД, да. Потом УМКД, дистанционные курсы, да? Или не то?
Нет, не в дистанционно, вот где у вас силабус, все документы. Я
Ну, в
могу,
УМКД, да?
я могу
Сейчас.
продемонстрировать вам экран.
Все. Вы вот так отправили, что ли? Все, я открываю.
Ага, хорошо.
Сейчас вот грустно. Так, ticket number 4, вот это describe maximum margin classification, describe structure, and the principal operation, in handling categorical data mapping ordinal features. Слово правильно, да? Все хорошо. Так, 30 минут, да?
20 минут.
Да, 20 минут. Сейчас я таймер поставлю, появится. Все. Я пока могу же выключить, да, звук?
Да. Are you ready, Alihan? I think you are ready. I don't hear you.
Я говорю, у меня в запасе 7 минут, но, как говорится, перед смертью не надышишься, да?
Да, вот вы правильно говорите.
Какой толк, по-любому, ничего не успеет. Извините. Ну, у меня тема такая сложная попалась. Я думаю, там, супервайз, там, что-то такое более-менее.
So please, we should discuss in English, okay?
Yes, no problem. So the first let me open. So the first question, my question is describe maximum margin classification with support vector machines. Vector machines. So okay. So what is a support vector machine? So the main objective of support vector machine algorithm is to find a hyperline in a n-dimensional space. N-dimensional means two-dimensional, third-dimensional, etc. So for what we use a hyperline? Hyperline in a simple put is just to how to say separate two classes. Just separate two classes of data points. So there could be many different type of hyperlines. For example, it could be for as I said before, for two-dimensional, for third-dimensional. It's everything depends on our features. So what else? So our goal is to find a plane that has the maximum margin. Maximum margin, it means the maximum distance between data points. So for example, we can imagine that we have data points and our hyperline which describes the maximum distance between these data points. So the main goal of maximizing these data points, the maximizing our distance provides some reinforcement. So in the future, data points can be classified with more confidence. So what we use hyperlines, for future to classify, for future classifying, etc. So where else? Also, I want to say about boundaries. Boundaries. For example, our margin could be small and maybe large margin. This distance directly depends on our number of our feature. For example, if we take feature number 2, the feature number 2, it means hyperline will be just line. Hyperlane will be just line. For example, if we choose feature number 3, our hyperline becomes a two-dimensional plane. And if our feature exceeds 3, it's some another plane, hyperline plane.
Okay.
Okay, this is about support vector methods, and in a short way, in a short words, hyperline. The objective of hyperline is separate two data points for future classifying.
Okay.
Okay, the first question is done.
Yes.
May I start the second?
Yes,
so,
please.
Describe the structure and principles of operation of a single layer perceptron. So single layer perceptron. So single layer perceptron. Single layer perceptron is similarly like multiple layer perceptron, but in single layer perceptron, how would say it? Just we sum up all weights. So in simple words, we have only one sum functions, and so we have some, for example, some inputs, and these inputs in some function just sum up all together. It's a very rough explanation. It's just how I conceive it. So what I can say else?
And how do you think why we by this course we discussed the perceptrons and what the relations, or maybe what's the previous story and connection with biology and the biology neural cells.
Yeah. So as I said before, no. I said as Muriel said before, she she came very good explanation about perceptron and about neural networks. That, for example, the computational neural network is the same like our brain neural network. It's all of and the function of perceptron, it's same when how we can think, because we see very different and very large information from our for example from our eyes, and
Yes.
in our mind, how to say, just decide what is it, and for example, it is okay, it's or it's not okay for me, it's danger, it's not dangerous.
So your reaction, yes?
Yes, your reaction. It's our mind, in simple put, just our CPU, our like a computer. It's just decide inside our mind. It's some algorithm, and our eyes is a sensor, just a sensor. We see
inputs of your signals, yes?
Yeah. Just inputs. We see any information. For example, I see, I'm seeing you, etc. And our mind decide what to do next. And the perceptron, the same thing. It's a lot of inputs, and a lot of inputs how to say, collaborates with them together. And for example, activational function decides what to do. May say about one example. For example, emotional. Do you know my dissertation? My dissertation
Yes.
is about emotional, and emotional. So we have very large data sets, with very different emotion. For example, laughing, angry, etc. And so we divided subtitle. We divided these emotions and put into the perceptron some kind of perceptron. In the perceptron, it's decide what kind of the emotion is it is.
To solve the classification problem, yes?
Yeah, solve the classification problem. Exactly.
Okay, thank you. I
like
think, yes, it's enough for this question. And the last question, and your answer.
Last question is handling categorical data, mapping ordinal features, partitioning data set into separate training and test data sets, selecting meaningful features. It's very difficult and really hard to conceive it. So what can I say about that?
Partitioning a data set into separate training and test data sets, it's very easy and very clear.
Okay,
please.
if we are talking about data set and training set, so what is training set? What is what is test set? So in the beginning, after preprocessing, preprocessing, we divided our data sets into two sorts. The first for training, and the second for test. And this division could be very specific, because two large data sets in training, maybe two large data sets in training maybe occur the wrong result in test, or too small data sets in training also maybe wrong result in test. Yeah, so we very how to say, very specifically, we should very specifically divide these data sets to training and test. So training sets, we just we tuning our model, our mathematical model, our mathematical pattern, and then test and data test requires to check our model. How does it work? Is it okay or not? And some kind.
What's the relation? What's the proportion between data between testing and learning data sets?
I got it. It should be 70% in the 30% or 80 or 20.
Yes. Why? How do you think?
Because the training sets definitely should be more large than test data sets, because it's training your model, and model should have how to say, its model has to be analyze more data. It means very qualifying model. Less data could be not qualifying model, and but it could be some how to say, it could be some mistakes in the model. For example, if we put very large, for example, data sets in training, it could be overfitting. It means our data sets will be reply exactly at that point, but model should be just approximate our data, it shouldn't not exact value, just approximate our value, for example. It's something like that.
Yeah. Approximate the behavior of these processes. Yes.
Approximate the behavior of the process. We just use linear or polynomial.
Excuse me. Yes, maybe